It's recording now, right?
Okay, it's now recording. Yes.
Oh, this thing. Okay, I just want to do. I want to do the man Whitney use for the age, so that we just know that we have done it.
Okay.
So that I don't forget age. So once and for all. That's 28593. 28593. Okay, I think I've done it. So back to what we were discussing. You know, go to that. Where did you see the feature is there? Let me explain to you. Where did you saw this feature is that? Go there. Go to the table you saw it. Okay, first let's change this one. You can change it now.
This one.
Done it. Okay, this one.
Okay. I should change it to my
Whitney.
Change
it to my Whitney is equal to, instead of T, say my Whitney U. Whitney. There's no E after T. No E after T. And there is hyphen. Hyphen between man double N hyphen Whitney. Exactly. U is equal to 28593.5. 28593. 59, not 51, no, 593.5. 593.5. P is equal to 0.042. 0.042. So you put asterisk there, is significant. Put asterisk, control 8. Asterisk, control 8 in your computer. Just press control and press 8 to put the asterisk there. Control 8, control on your keyboard and press 8. What are you doing?
Doing it, sir. It's not working on me.
Okay, well, no problem. And you go and copy the other one and put it there. Where's your computer from? Is it from Dubai? Or is it from Afghanistan?
No.
That is not having laughing. It's not having.
It's on the 8, but once I press it, it's not working.
Okay, maybe some of the keyboard. Okay. Okay, you put it there. You know, I just use it to indicate anything that is significant. Yes, it's an alert that, oh, this one is significant. If you look at the bottom of the table, I put it there, statistically significant. It's not pasting again.
It's not pasting too.
There is space there. You didn't copy it now. Yeah, right click, copy. Right click there now. Paste. Paste is. Why it has pasted. Now, to make it easy, put another line below that mean age, so that we put median age. Since we are using my left.
Sir, then another thing for this age, since it is not normally distributed, why are you using mean, not median?
That's what I'm saying. There's no problem. We are going to put the median also. There's nothing wrong. You know that mistake people are making. Whenever you know mean, median, and mode, they are measure of central tendency. If something is normally distributed, it is expected that mean, median, and mode will be the same or very close. So mean appear to now represent. If you say mean, if something is normally distributed, median will be the same value or very close to it. So there's no difference between the mean media and mode if something is normally distributed. But once if it's not normally distributed, the value of the meal will be different from that of the
It will be
media.
different.
So there's no point showing media without the mean. Even if you feel that it's not normally distributed, show the mean and the media. Showing the media does not mean you I don't know you some people just show the media. The mean you showed before is representing both. Yeah, because they are the same. But if it's not normally distributed, you show both the mean and the media, it will prove that though they are not the same. You get the picture. So put a line below that mean age, put another line and type median age. So that let me do the median.
I should insert another line below.
Yes, now. Yes, now. So the median age is 30.9, 40.4. No, 13. No, 30, 13, both of them. 30, 13. The median age is 30, 13.
13, 13.
Yes. So do that media very well. Push it to the wall now. No, you centralize. Yeah, what are you doing? If you select both, you just go and put the call centralize. What are you doing? You put it. You don't know how to use computer at all. I mean, you don't know more than you treat patient. You don't know what you select it. Select media age. Go up here. I'll show you where you are going to go. Yeah, click on this thing. Click on this one. This thing. No, select that. What are you doing?
Okay.
You have not selected it now. Select the media, sorry, and click on this one. Sorry, not that one. This second one. Yeah, click on this one. This second one. Yeah, click.
I clicked.
Now. You didn't click.
I should click justify.
Yes, now. I don't know what's wrong with your computer. If you click on that thing, click on that. You don't even need to. Just click on that icon there.
I've clicked.
I don't know where your own is not going. Because that's how to move it to that. Or even if you put your cursor in front of that media, if you put backspace, you should go. Put your cursor here and backspace. Don't select it. Don't select. Just put your cursor. Eraser. So now.
Sorry, sir. Back to this one. This p-value, is it 0.0042 or 0.042?
0.042. It's correct now. That's what I told you. It's correct. Okay.
Okay.
Now merge that line next to it. That line on media. Merge it with that line on with you, so that line merge it, so that it will not distort the table. So that the amount within you and the p-value they are on the line with, merge it with the line you have. Yeah, do it together now. Select the threes and the yes. Yeah, right click and match. Yes, okay. Makes sense now. So median age. Okay, go to the this is what you are talking, the parental. I want to explain the go to that one of those my Fisher is that. Let me explain that table to you for you to understand what we're saying.
This one. This one.
So how many cells is that in that place? How many cells in that
3.
table? Is it 3 cells?
3 for the primary caregiver. Yes.
There are
Parents,
3
relatives,
rows.
and others.
3 rows.
3 rows. Sorry.
How many cells? How many columns?
That would be 2 columns.
3 times 2. How many cells?
6. 6.
Is it not 6 you are seeing there? 2, 2, 4, 2, 4, 8, 25, 4, 4, 0. There are 6 cells. Number of rows times number of columns. Look at the number of cells. Now, what you are seeing there is called observed value. Observed value. What is called expected value. And that is if there is no association between the row and the column, that is the primary caregiver, and the group. If there is no, whether you are in camp or school, if there is no association between that 2 variables, what do you expect to be in each cell? That is the expected value. And how you calculate it, you look at for each cell, as you see observed value in each cell, there is expected value for each cell. But what you are seeing there is the observed value. For that 2, 2, 4 now, if you want to calculate the observed value for the cell, you say 2, 2 for the expected value for the cell of 2, 2, 4. It will be row total, that is total along the row. What is the row total? For you to get the row total for that row, it will be 2, 2, 4 plus 2, 4, 8.
25 plus 4.
Row total, I'm not saying
Okay,
column.
row, sorry.
2, 2, 4 plus 2, 4, 8.
225 plus 2, 4, 8.
That will be row total. But the column total for it will be 2, 2, 4 plus 25 plus 4. That's the column total. Can you see that? And which is the same thing. The column total there will be total along the column, which is the 253. You know the total there is 253 for the column. So for that cell now, the observed value will be row total, which is 224 plus 248, times column total, which is 253, divided by grand total. Total for all of them will be 253 plus 252. You know the total for the 2 samples, 253 plus 252. So for each cell now, row total times column total, divided by grand total. So now if you look at this 0, the one that has 0 now, the row total will be 4. 0 plus 4, 0. I mean, 0 plus 4 will be 4. Column total for it will be 252. 252 times 4 divided by the 505. It will be less than 5. If you try it. If you do the same thing for this one. So what is telling you that this row orders, that cell 4 and cell 0, if you calculate the expected value, it will be less than 5. But for this one that has 4, the expected value, and this one that has 25 and 4, the expected value will be more than 5 because the row total there is 29. 29 times column total divided by grand, so it will be more than 5. I don't know if you understand. But if you calculate for these last 2 cells, the 1, 4 and 0 for that
this
order,
0 and 4,
and this 4 for the other, the other line, that 4 on the other line, these 4, the last 4 and the 0. Both of them, if you calculate it, you can try it. If you calculate the something, it will give you, you can use your phone to do it. It will give you less than 5. So in that case, if 1 cell out of 6 is not up to 20%, is 16.7%. But 2 cells here is 33.3%. You get it now? So 2 cells now out of 6, 2 has expected value less than 5. It's more than 20% of the cell. Do you get the picture now? 2 cells constitute 33%.
Yeah, I get it.
1 cell constitutes 16%. If let's say it's only 1 cell that has expected value less than 5, the cascade is still value. Because 1 cell here out of 6 is not up to 20%. But 2 cells is now more than 20%. Can you see now? So many examiners also, many examiners also, they don't understand. Immediately they even see 0 in 1 cell, or they see a value less than 5 in 1 cell. They say, this guy is why you, but they don't know that it's not the observed value. The observed value can even be 0, and the expected value will be greater than 5. Doesn't really matter. So, but by the time you are beginning to see small values of cell, it may be a pointer that the expected value of some of them will be less than 5. It may be a pointer, but not necessarily, unless you cross-check. You get it now? So that is just it. So in that case now, if you are running SPSS, okay, share your SPSS. So let's go and run the same analysis. You're going to see what will happen. I will show you how you give the alert. The alert will be given to you. Even SPSS will give you the alert that there is something. Share your SPSS and let's go and run the same cross tabulation. You will see. Because when I asked you to do it that time, to transfer it, you just I have to come and correct you. You just wrote whatever you like.
We lack research background. That's our biggest problem. We're only into clinicals.
What is that? It's
I said we lack research background.
No, I don't think it's done research, but where its skill depends. Where let me tell you that some public health people also they don't know still. They don't know some of this thing. You'll be surprised. Or they are just struggling to know.
If you are doing research frequently, you will get to learn.
And why are you not doing research?
Maybe when I grow up. When I grow up, sir.
When you grow up to where you are not grown up.
A consultant.
Okay, no problem. Let's go to analyze. And descriptive statistic crosstab. Go to crosstab. Yeah, move the row. Move that partner. You know, caregiver. Is it caregiver or something with it? Is it the caregiver?
I think it's primary caregiver.
Yeah, primary. Yeah, look at it there.
Is it living arrangement?
Yeah, look at no, it's primary caregiver.
I should move it to row. I should move it to row.
And put it in row. Put the group in column. You know, group in column. Go to exact. Click exact there. Click continue. Click statistics. Go back. Because you didn't do what you didn't do what you are supposed to do. Analyze. You want to run the something that. Yeah, go to statistics. You have clicked the exact now. Continue and go to statistics. Chi-square. Click continue. Click OK. So show the result. So you will see something.
I've seen it.
What did you see?
6 cells. 6 cells. That's 60% have expected count less than 5. The minimum expected count is 50.
But it's not this one we did, Sha. It's not the. I think is it not the one we did? Go and check your result, your Word document.
Okay, this is the living arrangement. Is the living arrangement? Let me see. Let me do it again.
It's not living arrangement. Go and check that word. It's not really. I think it's one of those something. Go and check that Word document first. Not living arrangement.
Okay.
Before you.
It's primary caregiver.
No, we have collapsed it. You didn't. Okay, you see in my own, you didn't collapse in your own. I've collapsed it. That primary caregiver, we have collapsed it.
Okay.
Because they are, okay, let me see. Show the result. Show that result you showed the other time. Let me see. Let me see the output. Show the output. I'll tell you when.
Under that none, we collapsed it with others.
Yeah, none is with that parent, both parents and parents the same.
With relatives.
You didn't correct it, or me, I correct. Yeah, okay, when I was doing that, now crossing, I'm now corrected. Is both parents the same thing as parents. That's why that one is 224. 224. None and others together.
So that was why we are having 4 cells here. Plus this one.
Anyway, let me even mail let me mail my own version to you now so that you discard that one. Let me mail it to you, the express, because yesterday, if you really want to know what I did, I have already coded them inside the express. Let me mail to you.
Then the other question I wanted to ask, this one, because I have matched it for age and gender, does that mean that I can't really say which age is significant or contributes most or is gender?
What do you mean? The essence of age and gender is that if you now find anything significant, maybe between the group, it means that it's not the age that is contributing that problem. That thing is there. Age cannot be a confounder. You have removed the effect of age as a confounder. That's why you have matched it. It doesn't mean that something cannot be significant. Yes, it doesn't mean that something cannot be significant with that age. You understand me now? And gender doesn't mean.
I get you. So it means once it's there, it is truly because of that, since I have already matched it right from the beginning.
Exactly. So age is not serving as a confounder. Age and sex. If you say that people that are living maybe school camp are more likely to have this than school, it may not be because of their age or sex difference. Because you have already matched age and sex, mean that we have equal, we have the same category of age group on both sides. The proportion of the sex on both sides the same. Nigeria, the problem we have in Nigeria, when you even come to research, even the professor just carry mouth. They don't know anything about research. He just carry title. I'm telling you. You was there, you'll be wondering, we thought Nigeria has the highest number of PhD per population in the world. Where is it? In the world, the number of PhD we have per population here.
In the world?
In the world, that is if you say percentage of people that have the PhD for the population, Nigeria has the highest. More than US, more than England, more than China. They see, it just carry title. They can't
contribution.
Yes, they just become professor. You can just write anything. Is it not the end they said I made themselves professor? So that's just it. You see some politician engineer, they like put engineers also. The flowing guy, they don't know anything. Still, we cannot see anything that contributed to the country. He's an engineer by title, and he used to be deceiving people, to be shopping public funds. So it's a big issue in the country.
This is what is killing us now.
Your data. Let me just give it to you now. Data set. So I'll send you. You can wait if it comes. So I'll send it so that
Okay, sir.
you open it, you see what I'm saying.
Okay, I will do that one. So then the other question I wanted to ask you, this number of traumatic events.
Yeah. Go on.
Hello, sir. Like the number of traumatic events to PTSD, if like I want to relate, if there is an effect between the number of traumatic events, that table.
And what?
Let me share it.
And what?
And the PTSD.
We cross-tabulated
Post-traumatic
now.
stress disorder.
Is it not there? It's there
I
now.
know we cross-tabulated. I know we did. This is it. I was asking, can we use Spearman correlation? Why did we use Spearman correlation for it?
Yeah, we can use, yeah, we can do that. Then well, we can do that. PTSD, yes, no. But with the problem we have, we can use it, but you know, the PTSD is either the way the scoring is ambiguous. Eventually, it now become yes or no. Though we can use our biserial celery correlation.
Yes, it's either you have it or not.
We can do that.
Okay.
And resilient and all this one and see.
Okay.
Yes. But if you look at it from the study, the people that there's a correlation, because you can see as the number of events increase, the proportion with PTSD increases. Look at it now. For 0, 1.8%, 23.5, 52. As the number of traumatic events increases, the proportion that have PTSD increases. Can't you see? From 0 to 1.5, 1.8% to 23.5% to 52%. It's increasing. The same thing, percentile RAS score, as it's increasing, the PTSD increases. You know, the people with lower percentile RAS score, they have 0 PTSD. The people that have 4 and 34, and they are going up 12.5, 33%. And it's on both sides like that. It's on both sides. Both among the IDP camp and this thing. The opposite is the truth in the resilient. Can you see? The resilient. So as the resilient increases,
higher scores correlates to better less PTSD.
Higher score of what?
The resilience.
Yes, it's opposite way. The people that have resilient, they are less likely to have PTSD. And that's why all of them are now put. Yes, go and check the.
So as this.
Go and check the something now. Go and check the. That's why all of them are significant. That's why we put them in logistic regression. You didn't see it in the logistic regression.
So this 1 to 12 for this PTSD, yes, I've seen it down. I'm coming to. So this one resilience score 1 to 12 for the PTSD under the CAM, is it 0, 0 because the 2 cells are empty?
I'm coming. Hello? Hello, Alpha. The work is much. Only the work is much. Okay, no problem. Okay. Hold on. Okay, that's it. Okay. What do you look at it now? Which one are you talking of?
These 2 cells, this 1 to 12 for the IDP camp is blank. Is it 0, 0?
If you look at it, go and check the general Sunday, you know that no, in the IDP, nobody have 1 to 12. Go and look at the category where we tabulate it, go up. Nobody have 1 to 12 in the IDP. Is nobody have at all. Have PTSD.
Yes.
Go and check
Is
now.
0.
Uh-huh.
I'm there. Is 0. So what I'm trying to say, do you leave the place blank or you put 0 there?
You don't need to put 0. There's nothing there. You don't even need to.
Okay.
You don't need to.
Okay.
It's blank. Anybody that knows what it is, you know that there's nobody. And why it is there, if not because we are putting it side by side with the constellation, side by side with camp and school. If it's only for camp now, it will not even exist there. We will not put 1 to 2 there because 12 because it doesn't exist. But that 1 to 12 you put there. We put it there for both IDP and school. So that one is only applicable to the school, and it's only one that is in the category itself. If you remember, it's only one person. Yes, no person in that category for this one. So go on.
Yes. Then the other thing I wanted to ask her, so with this multiple logistic regression, I cannot say that a certain T has like a certain percentage contributed to it. I can only say that it significantly affects the outcome.
He will use it. It's cumbersome. We don't use that. We only use that one for linear regression. But there are some measure we can run it and show you the percentage, but the interpretation is not the same. It doesn't make sense. That's why you don't use it. It's only the odd ratio used to judge it. Odd ratio. You understand me? The odd ratio used to judge.
Then, sir, for this PTSD, where do you apply this Yates is it correction?
Yates correction. I didn't apply Yates correction. Why didn't I apply?
I know that was why I'm asking.
Why didn't I apply? Well, if you want the Yates correction, we can put it there and go and say Yates correction.
No, sir, what's the significance?
It's one nonsense thing. You know, the Professor Yates said that whenever you are dealing with 2 by 2, whenever it's a 2 by 2 table, only 4 steps, you find that the chi-square is not accurate. You now make correction. And when you make that correction, it reduces the chi-square small, the value of the chi-square. But many people, many statisticians also criticize it. That doesn't make sense. The chi-square also is a conservative test already. So it's a matter of, by many statisticians who argue. So, but sometimes the examiner will say Yates corrected as if it's, so if you want to put it, you can, even while we're running, if the express bring the Yates corrected out, it comes out. If you run it now, it brings it out. Which you can even put it in the front as Yates corrected. But to me, if you want to put it, you can rerun it now when you download that or this thing. All those ones are 2 by 2. Because Yates correction is only applicable to 2 by 2.
2 by 2 table.
Yes, can as well put Yates corrected. And the result comes out also when we run it, just that we don't pick it.
Yes, sir. Like from this work, if like you want to say, okay, 1 out of every 8 or 1 out of every 10 child has PTSD, how do you like get to that?
You are asking. I think I plotted a graph there now. Go to the left before the cross tabulation table. The table because of before cross tabulation, and the graph is there. Look at it now. And look at the graph, the prevalence of PTSD. When you see 1 out of 10. So this one is saying 15 out of 100 for the IDP, 50 out of 100 as traumatic, while 19 out of 100 for school. That's what it's showing now. The table is showing the same thing. The figure is showing the same thing. The only difference is that the table has statistics. Those of you say, they will say that why are you showing both table and figure? So you can go and write the statistic under the table and remove the table. And write the statistic in the table, the chi-square and the p-value. They will go and write it under the figure also, so that the figure has a statistic that is not statistically significant. So you can see that it's showing you that more of the people in the school have PTSD, but
PTSD.
But it's not statistically significant. what they tell you is just by chance that even the difference is not significant. You cannot say in that case, you cannot actually say that they have more PTSD in the school. But you can say that this is the prevalent in the school, this is the prevalent in the camp. The difference is not much. Are you following?
Let me check them there. Yes, sir.
What about? Who use what about?
Sir?
Are you the one using what about? Is it what about?
What?
What about? What about? Is it what
No.
about? Join my. Listen.
No, I'm not the one.
Okay. It has not come.
It has not come. I just checked the mail.
What happened? See, the thing has to first go to America before you come to Nigeria. Yeah. Okay, we can be asking your question when the time it comes.
Okay, sir. I'm checking my notes because when I was going through, I was making some notes.
Okay.
Sir, this result, how do you interpret this one, this adjusted odds ratio? Is it odds ratio now?
Yes.
Yes, this one, this crude and adjusted.
Crude just mean that for each of the, that our outcome variable is PTSD, yes or no. Then these are the predictor variable, age, primary health caregiver. If you see no stroke, yes, we are trying to see how many times the people that the primary health caregiver is not their parent is more likely to have PTSD more than the one that is their parent. No stroke, yes. So yes is the reference. No is the one you are putting, because the reason is that we have more of the people that is not their parent that are caregiver having more PTSD. We want to see how many times they are more likely to have PTSD. That is the odd, you give us the odd ratio. Like for easy on this one now, that first one now, the crude oil ratio is 5.38. It means that it's 5.38 times the people that whose parent, who their caregiver are not their parent, are more likely, 5 times more likely to have PTSD than those who caregiver are parent at their parent. You understand me now? The age,
yes,
the age is telling you that as age increased by 1 year, 1 unit, no, it's measured here. The rate of PTSD increased by 1.34. So what it means that if somebody is 14 years, another person is 15 years, that person that is 15 years that is older by 1 year, there's a 34% increase. There's a 34% increase. Can you say 1.34? 34% increase more than the person is older than by 1 year of having PTSD. That shows that the older, the more the PTSD. Do you get the picture now? Yes, now that's what it shows. The older. But the issue is that one, there are a lot of issues against that. As a young person what does he know about stress disorder? Yes, I mean, where you are a younger person may not be able to evaluate. And the older you are now, the more you are more likely to be there. Yeah, I don't know where it may not be so, but the older someone that is 80, if somebody is
may remember better.
With there. So that is just it. So now the difference between the crude and this thing is that for each of those crude, we run it one by one. We are looking at association between PTSD and age separately, association between PTSD and this one separately, each of them 1, 1, 1, 1. That's why it's simple regression. That's why it's crude odd ratio. Crude in the sense that if you run them one by one, you won't be able to, you have not removed the effect of confounder. Like for this one that is giving us 6 now, it's giving us 6. 6 is living with both parents. Those people that are not living with both parents are more likely, 6 times more likely to have PTSD than people that are living with both parents. But that 6 is a big figure. It may be it may not be the actual figure. It may be even be more than that in the actual sense. It may be there are some things that are confounding for it. So the crude odd ratio is what we call representing the relationship between the two variables when you are dealing with each of them 2 by 2 like that. The outcome and one exposure. Outcome, one exposure. When you now run everything together, all those ones that are significant, all of them, we now run it together. Both the primary caregiver, age, parent living with all those water shortage, we put all of them together to remove the effect of confounder. You now see that not all of them are significant again. That number 2 is no more significant. Number 3 is no more significant. Number water is no more significant. Can you see? Can you see? And we now see that the living with both parents, not living with both parents, is become about 9 times. Those people that are not living with both parents, they are 9 times. Before it was 6 times. So that shows that there are a lot of things that are even shortening the something. So in the real sense, if you remove confounder, it's up to around 9 or 10 times. So crude adjusted is you have adjusted for confounder. That's the meaning of adjusted. So when you are now interpreting now, you can say that you cannot say that, oh, so after adjusting for confounder, these are the factors. So your final judgment is this crude odd ratio. Those ones that are significant with multiple regression, they are the real factor. Not just like all those water that is no more significant. That shows that shortage of water does not actually cause this disorder. It's only that shortage of water is related to other things. Yes, I mean, maybe the people that are shortage of water, maybe those that are not living with their parents, are more likely to have shortage of water. The people that you know that a small child now, a parent will go and even go a long way to go and fetch water to let my child bath when you come back from school. But if it's not the parent, when you come back, you go and get water to bath. I don't know if you understand me now. Are you following?
Yes.
So
from these second ones that are really affected with PTSD is the age here, this age, then living with both parents, the total RAT score and the total resilience score.
So
those in IDP.
Yeah, it's not actually living. It's not living with both parents. Though. If you look at it, no. If you look at what I put for,
yes, no. Because it's a no.
So you say not living with both parents.
So those that are not living with their both parents are more likely to have the PTSD. Yeah. 9 times likely to have PTSD than those living with their parents.
Yes. Okay. With both parents, not their parents, both parents.
Both parents.
So total RAS score also, as the total RAS score increases, the PTSD increase. Can you see? So what if if total RAS score increased by 1, the PTSD will increase by 10%. Yes, I'm not. If somebody has total RAS score, let's say 20, another person has 21. If that person has 21, is at 10 times higher chance in 10% increase, not 10 times. 10% increase in the chance of having PTSD. Can you see that 1.1? Can you see how this is 1.1?
Yes. So now for this resilience score.
Yes, that is why the odd ratio is 0 point something. What is as the resilience score increases, the chance of the reduce of having PTSD, that's why the odd ratio is less than 1.
So it's a negative.
Yes, it's a negative. It means that as resilience score increases, the chance of PTSD increases. That's what you expect now. Resilience should oppose PTSD.
Yes.
So the same thing if you go
So
to
sir, now
gone. The same thing with
this one we did them separately for the IDP camps and then the school.
yes.
Okay, I remember. I get it
Because
because they are two different.
it's a comparative study, yes.
Okay. Let me check the mail again. Sir, did you actually go on your site?
On my side as well.
As in, is it in your sent or is still in your outbox?
You know, it has sent now. Let me see.
Why is it
Check
that I
again.
can't see it?
You see when there it has been sent. Reboot now, you have to refresh.
Okay, I've seen it now. It has entered.
Yeah, refresh.
I've been refreshing this thing.
I put it as
Before
Fatime.
it opens, I wanted to ask this question. Sir, this living arrangement for both parents, isn't it significant?
It's significant.
Because I didn't see an asterisk there.
Significant where? It's not you are looking at this table is comparing both school and this thing. So it's when you cross tabulate, you go and look at the cross tabulation. That's where you go to know if it's significant. It's not here. This one just telling you that this is different between the IDP and the school people.
This p-value less than 0.01.
That's what I'm telling you. This one is just telling you.
What does it imply?
It's telling you that the distribution of living arrangement in the camp is different from the school. That's all.
Okay.
If you look at it, 62.
Okay, so you have to cross tabulate and know if it is significant or not.
For you to know if it's a factor, it's under cross tabulation. It's not. This one is just this is a descriptive table, but because we are doing comparative, that's why you put it here. This one, the significant you are seeing is just telling you that the distribution in two groups are not the same. That's all.
It's different.
Go to the cross tabulation table now. The living arrangement is there. Go down. If it's going to be a factor, you know there. It was not significant. That's why it's not included in the. Now scroll down.
I'm there.
No, you are not there. The next table, that's where that one is.
Living.
Okay, living arrangement. Okay, I've seen it. Hey, wait. And that's why, is that not the factor you are looking at? Both parents. Living with both parents, not living with it's not the factor we are putting. It's significant here also. And that's why we are putting it in the logistic regression. If you look at it, the one that have the shortest, smaller one is both parent living. The other one, other mother, father alone or relative and alone, they are higher. The PTSD higher. The one that has the lowest PTSD is living with both parents. And that is why I now do, when you are doing logistics, and now living with both parents on one side, the other on the other side. So the other one, all those mother, father, relative are alone. They are the one not living with both parents. I don't know if you understand me now. Why this other one is living with both parents. So the one that are not living with both parents, they are more likely to have PTSD, and which we have shown.
Okay.
You can be living with father alone or mother alone, but if you not sometimes when you are like now, my wife is not around now. My son is here with me since morning. So you understand me now. So if a child is living alone with a one parent, if the parent is busy, imagine now as you are doing your research now, if your child, you are lonely with your child, so sometimes you will not get your attention. But if you are living together, if you are busy, it's with the father.
So let me go back to, sorry sir, I'm taking it one by one. So now I just want to relate for these demographic factors. We did a frequency table for it, and then we are also applied chi-square.
You are comparing the frequency table of camp and school. That's why you are putting chi-square. You are comparing the frequency table in the camp. Is it the same thing as school? So those ones that you match now, age and sex, you see that it's the same. For those ones you didn't match, some of them may be the same, but some of them are not the same. Most of them are not the same. That's why you are seeing significant difference. So what the chi-square?
So now for the so, sorry, I'm hearing, sir. What the chi-square?
So what the chi-square and the p-value is saying is to tell you if the distribution is it different in both school and camp, or it's the same. That's all. If it's not significant, that shows that there's no difference in the distribution. Like for this water shortage now, there's no different water shortage in the camp and the school.
Those in school.
But for food shortage, there's a difference between school and this. But it's quite different when you are now you want to look at the factor that is responsible for PTSD in each of them. That one will be a different thing.
So for this table 4, we only applied a cross tabulation for the BMI percentile.
For
the BMI percentile, this table 4.
Yes, now. Yes, now you do cross tabulation to see is there any difference, and there's no difference. The BMI percentile between the two groups.
Okay. And then what about the table 5?
And chi-square also, because
the frequency
is yes, no, yes, no. Each of them yes, no, yes, no, yes, no.
Okay.
It's chi-square also. If you look at the only one that is different, there are 2 of them. Hard life threatening.
In table 6, we applied Mann-Whitney.
Yes. You have chi-square also.
That was the one I was saying, Spearman.
Chi-square comparing the frequency for camp and school. Why the Mann-Whitney is comparing the mean or mean between the two. Forget about the mean. Okay. Well, some stupid people will say that if it is Mann-Whitney, is median. Okay, now that median is the same, it's 4-4. So what are you comparing? It's not median, it's comparing, just comparing the two. It's comparing the two, actually comparing the value in their natural state. Yes, I mean, know the other one, the one up, you have categorized it. This one is not categorized. You compare the value in their natural state. Either use Mann-Whitney or t-test. So it's 2 dimensions you are looking at now. The first dimension, after you have ranged it, even without ranging it, grouping it, the mean, you can Mann-Whitney will compare the 2. But for you to be able to use chi-square to compare, you have to first categorize to 0, 1 to 4, 5 to 8, 9 to 12 before you can use chi-square to do it. So you are trying to look at it from the 2 perspectives. But it shows that there's no difference. So there's no difference
between the 2 groups.
The 2 groups, whichever way you use to compare.
Okay.
So your table, you can decide to either IDP camp or camp. You know, some of them will put camp, some IDP camp. So you should, I will label
okay,
it.
I will label them.
Okay. That something to be methodology is not in the result. That last one, that Kolmogorov test of normality. Is
okay, this one.
Test of normality, yes, you cannot put it in the result. That's why I didn't label it.
Okay.
So it's going to be so methodology
In my
under your analysis.
okay.
Under your analysis, when you write your analysis, that's where you go to
Okay.
put it. That you did test of normality to see their. So for the fact that all of them are significant, I mean that they are not normally distributed, because that is far different from normal distribution. You are comparing.
So in that case,
you are comparing each of them with a normally distributed data set. If let's say it's normally distributed, p-value will not be significant. Do not be statistically different from normally distributed data set. I don't know if you understand me now. That is the meaning. So please, is the way I copy it to all those points, something is 0 point, you can correct it, statistic 0.93, 0.9.
at 0 point.
The way this brought it, I usually see just a point, but you can put 0 from.
Okay. So now, based on this test of normality, since they are not normally distributed, that's why I have to apply all non-parametric trace for them.
Yes.
So sir, that means that in that case,
let's go around it.
That man white you will be affected.
What
in
is
that case, that man Whitney, you will be affected. That one that we calculated man Whitney, you.
It's not affected. That is why you are using man Whitney instead of T-test, because they are not normally.
Okay, I get it. Yes, sorry. Is the Spearman rank I was talking about? Sorry.
We are not done Spearman
correlation. Let me share this my screen now.
Okay. So you are not sharing it.
Sorry, I'm trying to open it. See it now. Hello, sir.
Yeah. Yes. So see the way we do the cross tabulation. So go and split. Let me show you how I do the cross tabulation.
Okay.
No, we did it separately for both camp and school. So you have to split. What are you doing? I said you go and split. What are you sorting religion for?
Split. I've split.
Okay, go to.
No, that's a different one. I've split it.
Okay. Go to analyze.
Let me see, which one are you seeing?
Go to analyze.
Can you see?
Yes, I've seen it.
I'm on analyze.
Go to analyze. Analyze.
I'm there.
I'm not seeing it now. I'm not seeing where you are. Are you accessing it through? I'm seeing what you share, but I don't see your cause of analyze. Going to analyze.
Can you see now?
I've seen. I say, yes. Analyze. Cross tab. Go to descriptive statistics. Cross tab. So move column. Go and PTSD is down. PTSD. Slow down. Go to PTSD is down. Look at it. Move it to
one.
column. Move it to column. Age group. We start from how I put it in. Go to the age group. Age group that you group. Move it to the row. Move the gender to the row. Which other thing? All those social religion, ethnicity too. Primary caregiver. Look at that primary caregiver. Look at it. Look at it. So family living. No, it's living arrangement. It's not even family living. It's living arrangement, yes. Yeah, scroll down. I think the next one was we also do the percentile.
Socio-economic group.
Socio-economic group, yes. Yeah, it's up. I think it's down. Go to economic group. You didn't see it, Abby? It's SC. Look at it now, set group. No, the group
is there. I've put it.
That's it. Is the group.
I've changed it.
Thank you.
I've changed it.
It just appear now. It's low. So then the percentile. Put the percentile something also. Percentile group. Actually, it should be down now. But when did you define a percentile? Should be down. Percentile group. BMI percentile group. Should be down. Okay, actually, what I used was not even, no, don't even use it. Because I use underweight. Look at it. I put it underweight. You want under it, underweight BMI, yes. You know the reason. You don't remember the percentile group. The last category is just 111 obese. So what I do is to compare the underweight with the rest. You understand me now? Because
Okay.
Then this water category, this category.
Water shortage.
Yes, even before water shortage, there is this one. Okay, in the camp, here in the camp group, here in the camp group, here displaced group. Though it's only applicable to.
Yes, that was what I wanted to say. How
but
do
I
we
did
do
it also now.
It's applicable
to the. If you look at it on the table, it's only applicable to the camp people. Yes.
Yes, displaced group, and yes, in camp group.
Yes. Then the water shortage, food shortage, water shortage, no shelter.
You know, shelter is up.
Yes, now they are up.
The water shortage, I saw it down.
They are together. No, they are together. They are in the same place. They are in the same place.
I saw the water shortage down.
I don't know what type of water shortage that one. Oh no, that one. Well, you can use it. That's the one that created. You know, and you can use it. You know, if you want to do the logistic, even if that's the case, the other one is down also. I have to, you enter it as yes and no.
I did.
So I have to now enter it. I have to code them. But I know this water capital. I don't write my own capital. It's you that write capital thing. This water shortage is the one.
But I saw it down.
Okay, no problem. I don't know how it
go up.
Okay. If you cannot see, so if we see food shortage, go up now. Is around that something. Food shortage. Look at no shelter now. Look at them now. Food shortage, water shortage.
Put it there. I've put them.
No shelter. Then the next one we are now doing was your SLE group, RAD group, resilient group.
I have moved to them.
Yeah. So go to exact. Click on exact. Continue. Click on statistics. Chi-square. Continue. Click on cells. Click on row. Row percentage, yes. Continue. Okay. So share the results. You see plenty of them. So if you look at these are the things. So scroll up, go to that, you see that caregiver stuff. Ethnicity, age. Yeah, scroll down, go to that caregiver is after ethnicity. And that's all here. Can you see? So what it does, you know, it's got his two groups now. They camp up. So you see, yes, you know the way we go there. Yes, when you are writing it, if you look at the table, the yes is the one that first for write down. For primary caregiver, for parent, 26, 11.6%. Can you see? What is telling you that out of 224 that are parent, 26, which is 11.6, if you 26 over 224, is 11.6% have PTDSD, while the remaining 198, which is 88.4%, don't have. For relative, 10 out of 25, which is 40%, have PTDSD, and remaining 15, which is 60%, don't have. For others, there are only 4, 2 half, 2 don't have. That's 50-50. So can you see now? That's the way I put them on the table. So you have to write them out. You have to first of all use how to write them out before you go and transfer it. It's not a small job for you to bring a neat workout. It's not a small job. You cannot just go and paste. So this is for the other one. If you look at it, because there is no others for this one. For school, it's only 2 categories. That's why if you scroll down, go to the chi-square now. The first one, the chi-square is 80.101. The degree of freedom is 2 because there are 3 row, 2 column. But for the other one, the degree of freedom is 1 because it's 2 by 2. So what we are talking of that corrected, anytime there is 2 by 2, if you want to put the corrected, look at the continuity correction. That's the corrected chi-square. You don't bother yourself because why is cumbersome is that if you want to show it, you have to show it separately because you have to show its chi-square and its p-value separately. Unlike Fisher is that I just p. So look at what we were saying the other time. Look at it now. Look at for the first.
These three, so 50% have expected count less than 5.
So you see, in fact, what is telling us that 3 of the cells that show that even the other one has expected count less than 5. You understand me now? So 3 of this, you know there are 6 cells in that first one. There are 6 cells. 3 out of 6, that's 50%. Have expected count less than 5. Then the minimum expected count is 0.0. Even this one is less than 1. You know, when you say the minimum, it's telling you that it will be able to know if there's any cell at all that's expected count less than 1. You get it? When it give you the minimum expected count, even in this case also the minimum expected count is 0.6, which is less than 1. You get it now? So that's why we use Fisher in that situation. Does it make sense now? So whenever we are writing this up, once we see that we will write the p-value, we write the chi-square p-value, and also go and quote the Fisher exact p.
Exact test. Okay.
2T of it. Go and quote it also. And now put it. Okay. The same thing we did for this one. Now go and quote it. Since we have, but if we tell you that so, and you see that that thing is less than 20%, or even if it is 20%, it's still okay. And the minimum expected count is still more than 1. You don't need to quote Fisher as that. You just put the chi-square and their p-value. That's all. That's the logic. Does it make sense now? After I've done collated all of them, after I've collated everything, I now search for the one that are significant. And I went to do regression. I selected only the one that are significant. But before you can do the regression, I have to create dummy variable. Okay, go to your data editor window and go to variable view. Go to see the dummy variable I created for them. Is one of them you want to pick the other time you see water something. Go to data editor window. Go to variable view. Go down to the last set of hair. Look at it now. After the PTSD you see is okay. After the PTSD you see BMI percentage. That's what we did before. You see underweight. That underweight, you can expand that something. Let's see that column. Expand the column. Name column so that you can see it very well. Put your cursor up at the side name. On the title, the side name, yes. Yeah, expand it so that you can see all those things are written there. Yeah, expand it now. It's okay. So if you look at it, underweight, what I did was that, because I know that if you go and conserve, even before I did the conservation, I've done the underweight. Because what I did was that, the underweight has some, normal has some, but those obese and underweight, they are just one or two. It's too scanty. So I now discovered that the people that are underweight have a percentage, the people that are actually have, what do I call it? PTS. So what I just did is just to select that variable, BMI percentile, and now select only that one category, underweight category, and I say yes, no. So this one now, the one that are underweight will be yes, yeah. The one that are not underweight will be no. The other one, those normal overweight, all those will be no. Then primary caregiver, not parent. Can you see that? Primary caregiver, not. But what I selected. I made those one primary caregiver are not the parent, yes. I made the primary caregiver is parent as no. Can you see? Yes. Okay. So I'm trying to, because in logistics, the one you say yes is the one you want to put over against no. Yes, I mean. And because I want I want to make the people that their parents are the primary caregiver to be the reference. I want to know how many times the people whose primary caregiver are not parents are more likely to have PTSD than whose primary caregiver are parents. And here I now make the people whose primary caregiver are not parents, yes. And now the other one, I might make them know. You get the vision now?
Yes.
The same thing.
So it's going to be that one against the others.
Yes, thank you. So I use the people whose primary care are not parents, I use them against the whose primary care are the parent. You understand me now? So the same thing I use a parent, yes, not still married. You understand me now? We have still married and rest. And I put, because I discovered that all those not still married, the ones that are married, they are less likely to have PTSD. But the other ones, they are more likely, and I put them as yes, not still married against the still married. So yeah, not living with both parents. Can you see? I discovered the people that are living with both parents, they are less likely to have PTSD. So I now put those ones that are not living with both parents as yes, living with both parents as no. Then water shortage. I thought this is the one you were looking at. This is water shortage. Yeah. This water shortage